I'm Anil Kumar, sharing with you an excellent question on inverse of functions. The point 5, 1 is reflected on the line y equals to x plus 1. Find coordinates of its image point. If you really graph this, it is going to be a very simple question to answer. At present, we'll do it more algebraically, right? So let me approximately just sketch to give you an idea. From my sketch, I'm not really finding the answer, but I'm trying to explain you the approach, right? So we are given a point 5, 1. Let us say 5, 1 is somewhere like, let's say here, okay, 5, 1. So this is 5 and that is 1 for us, okay? And we have a line y equals to x plus 1, so it should go through this diagonal kind of, right? So let me draw a line here. This is a very approximate diagram, and that really helps you to figure out the solution, right? Now the question is, the point 5, 1 is reflected on this line, which is y equals to x plus 1, right? So this point is 1, y-intercept, and the slope of this line is also 1. Find coordinates of its image point. So after reflection, we are looking for image, so that means you could think like this, same distance away, right? So kind of somewhere here along this line where this distance is equal to that distance. So that is what we're trying to find. We're trying to find a point on the line which is perpendicular to this. That's the whole idea, right? And this point is given to us. Let me call this as P as 5, 1, correct? So I hope now the question is clear to us. We can actually find this point, which is the intersection, and then same distance away we'll find its image, right? So let me call this as P dash. Let's see where it is. Okay, so what we have here is that we are given y equals to x plus 1. Clearly slope is equals to 1. So a perpendicular line slope should be how much? Minus 1, right? So let's say m perpendicular will be minus 1. So we can write equation of that perpendicular line will be y equals to minus x plus b. To find b, we can substitute the point p, which is 5, 1. Since that perpendicular line passes through the point 5, 1. So let me call this as L1, right? So we are finding equation of line 1, which is perpendicular to the given line. Is that okay? So that is what we're trying to find. Now if I substitute x as 5, y as 1, we can find b, right? So we have minus 5 plus b, or 1 plus 5 equals to b, which is 6. So therefore this line is minus x plus 6. So let's name these equations. So we found equation number 2. Equation number 1 is the given equation. So we now know these two equations. This one is y equals to minus x plus 6. Knowing that, we can find intersection of these two lines. So we have equation 1 and equation 2. So if I add equation 1 and equation 2, that is to say, if I add these two equations, let me highlight them, okay? So equation 1 is this one for us, and equation 2 is this one for us, right? So we are going to add them. If we add, we get 2y equals to minus x plus x cancel out, plus 1, plus 6 is 7. So y equals to 7 over 2, which is 3.5, right? So y is 3.5. And if I substitute y as 3.5 in equation number 2, then we can find x, right? So the idea is to find x. So x is equals to, let me rearrange this. So x is equals to, I mean, if I take x on this side, then it is minus, right? So it is 6 minus 3.5, which is 2.5, correct? So the point, let me call this point as O, okay? So point O for us is x value of 2.5 and y value 3.5, right? So that is what it is. It kind of makes sense. So what you observe here is that you have moved from here. This is 5, right? So this point is x value of 2.5, right? And the y value is 3.5. So you have moved 2.5 left, 2.5 up, right? So if you compare with this, let me just enlarge this point, right? So we have this orange line, okay? Let me redraw this. Let's understand this portion, right? So I'm just sketching this line again here. Okay, so a big view. So what we have found here is that this point P is 5, 1, and somewhere in the middle we have a point which is 2.5, 3.5. Is it okay? And that we are calling as O. And same distance away is our point, which is the image of this point. What is that? So you can see from logic, from here we've moved minus 2.5 and up plus 2.5, right? So, and came to the center. So if I again repeat this process, minus 2.5 and up 2.5, I'm going to get to this point. That is to say, I'm taking away 5 and adding 5 to get to this place. So if I do that, that is minus 5 and plus 5, I get the point 0, 6. Do you see that? So I get P as 0, 6. So that's an easy way of finding P dash the image. Well, here's the alternate method. Alternate method is, this we got from logic kind of, right? So let us say these points are x, y, right? We don't know what this is, but we know the midpoint, right? So we know the midpoint is 2.5, 3.5. So x plus 5 divided by 2 should be equals to 2.5, right? Since that is the midpoint. Similarly, the midpoint of y is 3.5. So y plus 1 divided by 2 should be equals to 3.5. So we can solve for x and y. So we get x equals to, or let me do in 2 steps, x plus 5 equals to 2 times 2.5, and x is equals to 2 times 2.5 minus 5, which is 0, right? And here we can say y plus 1 equals to 3.5 times 2, right, which is 7. And y equals to 7 minus 1, which is 6, correct? So we get the points 0 and 6, which we anticipated earlier. So the image point in our cases, we can write down the answer. Image point is 0, 6, right? So it is this y-intercept in this particular situation. I'm Anil Kumar, and I hope that helps. I'd like you to go through these steps, understand. First step is write the equation of a line perpendicular to the given line passing through 5, 11. Find their point of intersection, and the image will be same distance away. Use the midpoint, mid of a segment point formula and use it and get the result. I hope that helps. I'm Anil Kumar, and if you like the approach, you can always put some likes there. Share and subscribe my videos, and if you have doubts, ask questions. Thank you and all the best.